All right, Mr. Claxon's Algebra 2CP class. Right now, I'm coming at you from the classroom in order to help you with solving these word problems by using systems of linear equations. You can see that's the goal. Very, very important that we consider units. Okay? I know that you could pause and read this if you wanted to. We also have to consider that we got to create two equations from given information and implied information. And we're going to talk just a little bit about what that implied information is. We discussed these examples yesterday. They're in your notes. You could go ahead and get your notes out to review what we discussed. We then completed two examples together in class. The two examples that you were supposed to look at last night was, one, the difference, given the difference of two supplementary angles is 36 degrees, find both angles. Now, you can solve this with a single variable system. Miss Buzzio is very good at doing that, or you can use two variables. We are focusing on the two variable system. That's what's going to create our system of equations. The dimes and nickels problem is very, very important to consider. Now, many of you probably came up with 0.10x plus 0.05y equals 0.085 based on the given information. You can see all we did to get this equation right here is multiply the entire equation. We multiply the entire equation by 100. Okay? You'll need that skill to solve by using elimination. So let's go ahead and take a look at a problem. And all I'm going to do is verbalize it, maybe underline some key aspects of given information. In the first example that you had to do last night, what you needed to do was underline what the question was asking. How many of each? And you really do need to consider each of what? Each, are we talking about shirts? Are we talking about pants? Oh no, we're talking about dimes and quarters, right? So how many dimes and how many quarters? Some people will need to reverbalize that. Go ahead and write that down as how many dimes and how many quarters. So reverbalize that question if you need to. How many dimes and how many quarters? So sometimes the questions are real vague and you need to do a better job of specifying, or figuring out what exactly is this question asking me. Now we have this given information. So our given, we have two pieces of information here, which is total of $2.55. And the other piece of information is that you have 15 dimes and quarters. Now, could we have abbreviate that? We just call those coins. You have 15 coins. So there's given information, and then we have some implied information here as well. The easiest given information to write an equation about, excuse me for that, is 15 dimes and quarters. I know that what that's telling me is I have 15 coins. So if I let x equal, and that's why it's really tough, let x equal number of dimes and y equal number of quarters, I know that x plus y is going to give me 15. Okay, but I have to define my variables as such. Now, with this equation up here, you have some implied knowledge. The implied knowledge here is that you know how much a dime is worth and how much a quarter is worth. So this is where you would start with 0.0 and I always like to put 1, 0 times x. Why do we multiply it by x? Because that's the number of dimes we have. Increased by 0.05 times y. That is set equal to $2.55, or 2 55/100ths. I now have my two equations. I want to write them as a system. Write them as a system. And solve. Now, in the process of solving, you're going to have to multiply this equation right here by 100 to make things easier for yourself. So multiply that by 100 to get 10x plus 5y equals 255. Then you're going to have to determine which variable you wish to eliminate and multiply equation 2, the red equation, accordingly. You would then either add or subtract your equations to solve for a variable, and then plug it in, plug it in. Let's go ahead and move on to the next one and just talk about the implied knowledge. The implied knowledge is that you know what perimeter is, and your implied knowledge is actually the formula for perimeter. You'll have to excuse Mr. Spurgeon yelling loud. I apologize if you can hear that. Perimeter is equal to, and after you identify your variables, W and L, perimeter is equal to 2W plus 2L. Typically we write L, lowercase l. I always write a cursive L so it doesn't look like a 1. Now in this case, the perimeter is 30 feet. So that's one of my equations really has been given to me with that implied knowledge. So I just replace P with 30. Then I have the length is 3 feet more than the width. I can write an equation from this. Length is 3 feet more than width. I don't know if you remember the reading strategies we did at the beginning of the chapter, but that is just going to be L equals 3 plus W. Now you're going to have to rearrange that to get the other system, but you should be able to solve it after you get both systems of equations. So what I want you to do is I want you to make sure that you have 1 and 2 correct. And how do you check to see if you're correct? Plug it in, plug it in. All right. We have some other example problems for you to look over, and I want you to get started on trying both 1 and 2 in the next section. If you can't do those, then just go straight to the homework, solving each word problem using a system of equations. And I'll be back in to answer any questions at the end of 5C. I thank you so much for listening, and yeah, happy equation solving. It's good stuff.